So I hope you are seeing my desktop right now,
Yes,
right?
I'm good.
Yeah. So we stopped in keywords in last session. From there we move forward. Right. So next thing that we want to discuss in about embedded C is the statements in embedded C are terminated by semicolon that is considered as sentence terminator. This is applicable to the C that we use and C that we use. Right. So that is common. Some of the programming language, they don't use a specific sentence terminator. Let us say we have Python. In Python, we don't have any explicit character. The new line is used as sentence terminator, right? Here we have this specific symbol to terminate a programming statement, which means that you can even have multiple programming statement in a single line. You have to terminate them by colon, right? So that act like a separator between programming statements so that the program counter or microprocessor controller will understand its execution sequence, right? That is the use of that. When you have more than one statement and want to run them when a specific condition is true, you can group them using brace. I believe you know these things. These are very basics with respect to C that is applicable to embedded C as well. Right. Then data types. With respect to data type, we have char, int, long, double, short, like that. We have different data types in embedded C. What is their size? The size, the people used to say, okay, character means 1 byte and integer is some books it is told like 2 bytes, some it is 4 bytes. Like that, we have different conflicting explanation or a range for these data types. But actually, when you want to understand the exact size of these variables, these data types, the size in which they hold the data, that depends on microcontroller or microprocessor. That is what the correct answer. We cannot say that integer is always 2 byte, integer is always 4 byte. The integer is sometimes 8 byte. When if your microcontroller is an 8 byte microcontroller, you are going to do a embedded C programming for a 8 byte microcontroller. In that case, your int, the size of int is only 8 bit, sorry, that means 1 byte, right? So when you do the same for an 16-bit microcontroller, then the size of int is 2 byte. If it is for a 32-bit microcontroller, then it is for then the size of int is 4 byte. So it will vary, right? The same is applicable to short as well. If it is a 16-bit controller, short is 8 bit, that means 1 byte, right? So if your controller itself 8-bit controller, there is no meaning of differentiating. Your int and short will have same size. So like that we have. So from this, what we conclude is size of these int, long, double, short, this will vary based on the controller you use and based on the floating point logic that they support. Right. In double, in some microcontroller, it is 4 byte. In some microcontroller, it is 8 byte. So we have difference. So the best way to study, best way to know the size of variables that you use with these data types in any microcontroller, study their compiler and study their microcontroller datasheet. That will answer you. Right. So you cannot make a blind judgment or blind assumption that int is always 4 byte, int is always 2 byte, something like that. We have to be clear in that. Okay, no? That is one thing. Then how you can declare variables. Your But as far as the character is concerned, in embedded C, everywhere, even embedded C or NCC, everywhere the size of character is 1 byte only. There is no difference in that. Right. The scope of variable. Scope. Scope means availability of variable in while you execute the program. Right. Some variables are available only in a function in which they are declared. Those are called as local variable. You have a function in that inside that function you have a variable declaration that is available only to that function. You have a main function in your program. You declare some variable in the declaration section of your main program. Then that variable is available within your main function. You cannot use it outside your main function. But you declare some variable in a separate file or outside main. That is considered as global declaration. The global variable that you have, right, that is accessible by every functions that you have in that file. Every functions in you have in that file, but you cannot access them outside a file. To use a global variable declared in one file in another file, we have a keyword in C called extern. You can use that. That is available in embedded C as well. So whatever the global variable that you want to use across your projects in different files, declare them in one file and extern them in the file or program where you want to use them. Right now. So you can go like that. So that is called as variable with global scope. The local scope is you are declaring a variable within a main or within a user-defined function. Those are local variable. Right now. Right now. So the functions that you write in embedded C is also have some sort of data type. They used to call them as return type right now. So I have a function which counts from 1 to 100 and return a number after counting. Or I have a object or a array which is having a series of numbers. I want to count them. I can pass that function to a function called count and it will return the number of objects that we have or number of element that we have in that array in terms of numbers. So the return type is called as the return type or the output result. Data type of output result is called as return type. Sometime these function return type can be int. In for some functions it can be a character. For some function it can be void. Okay, if it is integer, okay, we are going to get an integer result. If it is a character, we are going to get a character result. If it is void, what it means? What is mean by void? When a function has a return type as void, what it means? Because, come on.
It means it's not returning anything. It's
Yeah,
empty.
it is not going to return any result. It doesn't mean that it is not going to do anything. If return type of a function is void means don't think that that function is not going to do any job. Not like that. It can do. But after processing, after running that function, the caller of the function will not get anything. See, I have a main function. In that, I use count function to count number of elements in an array. After counting, the count function will return a number to main function. Maybe I may have a variable in main function in which I can store it. Right. So this is called, this is like a function which return a value. I call a function in main that prints some messages in the screen. But it is not going to return anything to the main function, right? If that is the case, that return type is called as void. It is a special type used only with functions and pointers, right? We'll study what is void, pointer, and other stuff. As well as the functions are concerned, if they are not returning anything, using void is very common in embedded C, right? And then the functions that we have in embedded C, right? They can also accept inputs from the user or input from the programmer. They can accept parameters that they want to use it when they run the function description or function description that we have written, right? Function logic. When they want to execute, when they are executing that function logic, they may use the parameter that you pass. My question is where these parameters are stored. Are they stored in program memory or in data memory?
They will be stored in data memory. Sir.
Data memory. Data memory in a in a laptop is RAM, right? So in RAM, we discuss three things: stack, heap, and then rest of the RAM, where they are stored.
In stack answer.
Why?
So they will be stored as part of RAM.
Can I store? Can I store a function parameter in heap or RAM, rest of the RAM? That means other than heap or stack, can I store like that? If I want to do like that, how I have to declare those parameter?
You need to change the data type answer.
What
Register you
data
can.
type? What data type that we have to change?
We have data type register.
Okay. Okay. So
Sir,
you
some
you, you mean
keywords
to. Hmm, hmm, hmm.
like some keywords are there, sir. Malloc, Kellogg, like that. I remember.
That
Some
is for dynamic memory allocation to allocate the variables in heap.
okay.
Yeah, that is true. To see here, I have a int fruit like that array, right? Maybe that may have some numbers in that fruit array. I want to count them. But by default, I'm saying that what Amir told is the fruit array will be stored in the stack. That is what he told. But I don't want to store it in stack. Can I store it outside, like in rest of the RAM or somewhere? Is that possible, first of all?
Yes, answer. We need to change the memory address.
No, there is something. Let us investigate that first by using a simple program. See, let me create a program. Right. So here we have programs. Let me create a program called count fruit dot c. Right. I have a program here. Stdio. Then I'm going to count fruits. So I need the fruit function. I have to define a fruit function. In C, when you want to define a function, you have to prototype it. Prototype means you have to declare it return types and then how many arguments are going to be for that function, those details. Let me declare that now. That means I want to prototype the function now. Int count, int fruits. Right. So this is, maybe I can, you can even say like this. This will work. Int star, which means it is going to be an array. Right? Then I have to terminate that line with a semicolon. Then I have main. Here you can see a difference. I didn't give int main, instead I just give main. Is it correct syntax? Do you think that is correct syntax? Come on.
By default, it will take void.
By default, it won't take void. It will take a different data type, what it is. When you don't declare your function as void or int, by default, it will assume int as data type. That means return type for main. That is the actual return type of main. Though you don't specify it explicitly, they will consider that by default. If you want to have your function as void one, you can explicitly say it is void right now. So to understand, to make it understand, I am not declaring a function with int now, right? Let me have some fruits here. We have some sort of thing, fruits array, 10, 50. So these are the three different fruits, their counts. Now we are going to count all of them together. So actually we have to add them to count the total fruits, right? So what we are going to do in main, I am just call, I have to define, I have to write description to this function, right? Count of int there are three different kinds of fruits. We have what their count individually. 30, one fruit is, we have 30 count or 30 numbers of that. Another one is a 10, 50. So to find out the total fruit count, we have to add them. That is what the thing, right? So we say total count equal to 0. Here, I just say count total count plus equal to, otherwise equal to total count plus fruits of rider. Then the rider is incrementing. At the end of the day, we can print return total count. Right. In main function, I just call printf. Before that, let me do like this. So I can say int total fruits. Right. So we call total fruits is equivalent to count of fruits, which is a global variable. Whatever that I declare it outside the main. So it is global. So I can access it anywhere. I can access it within a main. I can also access it within count. But within this file, I can use it. Right. So count of fruits. That's it. Print total fruits are percentage D. Maybe we can have a slash in here. Right. So I have to say return 0 because by default they assume it as integer. So I do that. Let us check whether they are really assuming it as integer. As I told, I just comment this line. They will throw an error. Right. So now I come here. GCC count fruits.c output object count fruits.exe. It's showing some error. The first thing is error expected comma or semicolon before int. Maybe I think we are missing some sort of terminator here. We are not using terminator that we fixed
Third line on sir.
in line number
3.
3 also, right?
Yes.
Line number 3. Yes, we didn't put a semicolon there. Now it is correct, na? We don't have any issue. Let us run it now. Still, it says expected equal to comma before token. Why? Maybe I think it is confusing. Let me do like this.
I'm sorry, for main, you need to open the brackets, I think, which is written as main.
So in line number 7, you are talking?
Yes,
Number
main.
7. Yes, thank you. Yes, you are right. So let me comment this now. What it told? See, warning, return type default to int. What it says, you didn't provide any return type, so I assumed integer. Like that it is saying, but program will work actually. But it says I assumed you didn't give any explicitly, you didn't define the return type for main, so I assumed main. It gives that as a warning. If it is something else, you just specify that. That is what it's meaning. So I just count fruits. Right. Perfect. It does the job. It says 90. Is that correct? Yeah, it is 90. So it is counting. Actually, it is adding, which is equal to total count of fruits. Okay, now the question is where these variables are declared. So if you are just a programmer for computer, You no need to bother about them. When you are an embedded programmer, you have to know where they are stored. Right. So let us do them one by one. Let us do that assessment one by one. Here also, I didn't specify any storage class. Right. So I just declare them as int. When we declare some variable with just a data type, where they are stored by default, because I told that from the day one.
It will be stored in the stacks.
Stack. By default, storage place for all variable is stack. When you want to store them in a specific area, you have to explicitly specify them. Right. You can use to specify that, you can use the storage class register, static, something like that. Right now. So let us understand one by one. First of all, what I am going to do, I am going to print the address of these fruits and counts. Moment I come in, I just say print address of fruits percentage x. On that day we day the x only, no? Percentage 0x percentage x ux unsigned x. Then we pass address of, I think we have to just pass fruit. You can ask me a question. When you want to know the address of a variable, you just store percent ampersand in front of that. When it is an array, we need not. Actually, array means it's just like a collection of memory locations. So the first memory location is stored is given to that name. So automatically you will get, if though you don't use ampersand, we can get it. But if it is a variable, then you have to put an ampersand in front of that. So I can get an address of fruits in which it is stored using this syntax. But for count, actually it is a declaration. So here there's no memory allocation, no data storage. So after that, I am going to know address of this total fruit. But here I have to say ampersand. Right. Then that is the another variable. And then I have the variables here.
Sir,
Do you think, do you
you,
think, yes, yes,
sir, in the 10th and 11th line, the semicolon.
thank you.
Yeah.
Right. Do you think this fruit and this fruit is same? Both of you
No,
believe that?
no answer different.
Different. For this fruit will be there in a different memory location, and this fruit is in the different way. Even you can have that as like A, B, something like that as well. You need not to have same name as fruits. Even if I give a same variable name fruits here, it is not same because it is a parameter for this function. For this, they will reserve a separate memory. Right. Let us understand that now. So address of right. If I change that to A, I have to change it here also A. This rider also stored somewhere. This total count also reserve a memory. So these are the different memories that variables that we use here. All of them are stored in stack. Address of rider, address of total count, see the difference. When it is an array, I just use the name. When it is a variable, I prefix a ampersand with that. Right. So that's all. These are the different variables that we have. They are all, as of now, we assume them. They are declared in their stack. We are going to inspect whether they are really stored there or not. Right. So they are stored in the same location, we will have a consecutive memory location. Let us check that now. So I think I'm using Python keywords here. Sometime. Okay, in line
In the
number.
function also, in functions also, it's print on this.
Sorry. That is what you have to be expert in only one language. When you try different language, you will forget one. Okay, again it says it compiled anyhow. So I can now explicitly say that is validated. So by default, they assumed integer as return type for main. So if it is so, you have to use a return 0. Otherwise, they will throw some warning. So after doing it, we have this. Let us run the program now. Just compile it one more time. Everything went perfect. Okay, I think we have overlapping. So to fix that, we can use a slash in front of them. Right. 4 2, let us see from this thing. Fruits is 4210692. Right. From there, very interesting. 642. Is it some sort of truncation happens? 4210692x. This is a memory location that is different from, I think they are printing. Very first thing is address of fruit, right? Address of fruit, as it is a global one, it appears to me they store it in the stack but not in consecutive memory location.
I'm sorry, global variables will be stored in another location, I think. They will be having some BSS and other in memory layout. We will be having.
I believe, yes. So they are not stored in the stack, these global variables, right? The fruits is global variable. So 4210692, right? That is the address of that. It is not the address as we have for these variables. Like after next variable that we declared is total fruits. For that, they say 6422300. This is a stack memory location. And then address of A that we are having as a parameter right now. So that is also having the same address 4210992x. How it is possible? See, A is address. Okay, when we are calling it, we pass that one. No. Our aim is to understand the address of A. Same address is coming, right? 4210992. 692. So as fruit is
In both
paused here,
places, you're passing the array answer, so it will be the first address.
correct. It is first address only. My question is, these fruit and this A are two different memory location only, right? Do you agree? See, they are not same. The fruit is a global. A is a parameter for the count function. For that function, we pass fruit. But when they are printing it, what they do is they print, okay, when you pass an array to a function, they use it as a call by reference, which means that they just pass the address. They don't make a copy of it. If it is a variable, the concept is different. Correct. I think that logic I forget.
Yes,
So
sir.
see, when you pass an array to a function, they use a method of call by reference. Call by reference means they won't make a copy of it. Instead, they will use the address of it. That's why we get the same address for because we are this function is called only after we pass the fruit. Only after we call this description will be executed. The address of fruit is this one 4210 692. So that is printed. Okay, that is obvious. But with respect to these variables that we are talking, total fruit is 6422300, and after that this one. No, I think I have to put a different word here. Rider. Here it is. Total count. Right. That is what it is. The address of rider is lesser than this 300. Right. It is only 252. And for next variable that we have is total count. For that 642, 642248, which is less than this 52. Right. And then they are printing it. From this, what we conclude is our variables that we have in the main as well as these within the functions, they are declared in stack. Right. As this is a global array that we declare, they use a concept of call by reference. That's why we get only address. But the global variable is declared in a separate memory location, not in stack. So it is not declared in the stack. It is they use a different memory. I think it is something different from stack. So that's why we have a difference, right? But now
So
I want
array
to,
is in
yes,
not in stack, sir.
the array, this particular array is not stored in a stack, but actually it should be stored in a stack. But within the stack, they have b dot bss, something like that. They have a division. They store it in a different memory location, not in the consecution as we store these variables, right? Variables value, they are not storing it in that way. That is how the result shows. Now let me do a different things now. I just stay static. I change the storage class. I also do the same for array. Static. And then, right. Obviously, it will be different memory location. What we can do is we can have another function. It's another prototype. For that, here I say int print num static int n. So we'll have different name, static int m. Here we need not have a variable name, that is not required. Right. So I say here static num 10. So that is a global static variable. Then I pass that variable to this one. So here also I say print address of m is right. So I think we have that makes sense. So we can even print value of m equal to %d comma m. Right. So this is just we are passing here we pass an array, here we just pass a number. That is the difference. So I made both of them static now. Right. Let us see what happens when we call this print num. Uh, mm, right. Perfect. But did we print address of m? I don't think so. Address of num. We didn't print that. Perfect. So we pass that and we count the fruits. When it is passed, they will come here. So this m and that num is different. Now we won't get the same address. Let us see whether we are getting it. Do you have new line for everything without any issue? Storage class. Storage class specified for parameter A. Okay. Defaults to int static num. Okay. I think as I told like that, it is static int. Storage class specified for unnamed parameter int. Error. Storage class specified for unnamed parameter int. Okay. Storage class specified for a parameter specified for parameter m. Okay. Brilliant. Then storage class specified for parameter a. What is wrong in that? So from this, what we come to know, we can't declare these parameters into static. That means in rest of the RAM. That is what they are trying to say. Maybe let me change this to static. Let us see what happens. Same error. So from this, the parameters that we use as input to function cannot have the static storage class. If we remove it, all of them will work. Print int, and then this static is not required. So we don't require them. But functions can have, variables can have, arrays can have, provided print num. Okay, I hope that makes sense. It does the job. See, address of fruits. It says an address, and total fruits, address of total fruits, it reserves in stack, and then as it is a call by reference, we get the same address. And then address of A, which is address of num. Okay, because we declare that as global, right? So it is going outside the stack, right? It is a different memory location, which is is it very closer to 4210, but it is 4210, okay? 704, but it is 692. As we have series of numbers, we have this value, I believe. Right.
Fruits and num are same answer.
No, I didn't get you.
Address of fruits and num are similar.
Address of fruits and num, yes, that is similar.
Yeah, after three elements, we have started with num.
Yeah, because each one of them are 4 byte in size, so that we are getting 704 right now. After that, A is because it's a call by reference, we passed that to fruits. That's why we are getting that same address. And then rider. Rider is again going to stack. Total count going to stack. M. See here. Is that the same address? No. Because M is a local variable. That means, see here, when actually the num is a global variable, when it is passed to print num, they make a copy of it. They are not using the same address. See, when you pass the fruits to, that is why I want to create this single variable functions. Otherwise, we can complete with the array itself. If you look at the behavior in the address, when we are also printing here, after we pass that fruits here, we try to print the fruits, address of fruit. Address of fruit as well as address printed by the count, both are same. Because as it is an array, they are used call by reference method. So only the address is passed, there is no copying happens. Right. So we get the same address. Whereas when the num is a global variable And when we pass num to print num function, and when we try to print the m, which is actually a parameter, it has a different address. Why? Because it is a single variable, as they use a concept of call by value method. Call by value means when you pass a variable to a parameter of a function, they will make a copy of it instead of using that variable as such. See, that variable address is num address is 42107 421000704. That is what its address now. If that is the case, m also should have the same address as we are passing it if they use call by reference. But here they use a call by value. When we use a call by value, what they do is they take the copy of that variable in the stack first, and then they process everything using that variable, right? But you will get the same result. Whatever that we have in num, we are getting when we print the value of the value of num is 10. That is coming when we print m. But when we print address, the address of address of n, num and address of m is different. Why? Now you understand, right? The reason why we get the same address when we print address of an array, why we get the different address when we print the address of a parameter passed to a function. So this is called by reference, this is called by value. We will study that in detail. That is not our goal now. Our goal is to understand whether can we declare a parameter of a function as static. That is the question now. We can't. We try to declare it, it throw error. Well, because all parameters that we pass to functions are stored in the stack memory only. Either in stack or it uses the address directly. If it is an array, call by reference method, they do that right now. So one another thing that I want to explain you is, this is very common in programming. Here I only told int star. That is what I told, which means that I am going to have a pointer. But I am passing an array which is fruit, which is having a square bracket after the fruits, because it is an array. How that works? It should throw an error. No, you have to pass only pointer. You are not passing a pointer. So you are passing an array. It should throw an error. No, why it didn't throw that? Come on.
Array is a pointer array. Sorry.
Star in the front and the square bracket at the end, both are same. That means when you prefix a star with a variable name, it is a pointer variable. When you suffix a square bracket with a variable name, that is an array, that is also a pointer variable only. So it is a different way of saying, representing the pointer. That should also be clear to you. So I can even, I may have said like this, some f of, I can do the same result. I will get the same result. I won't get a different result. Right. But instead I just said star. Why I just said star? Because after I declare that a star, I am going to pass a point. I'm going to point an array. Array is nothing but the beginning address of a collection, right? Which is again a pointer. That's why when I pass an array to that function, it didn't complain. It simply accept it and it process that, right? Is that clear to you now? So what you can do with function declaration and parameter storage class declaration, what you can't. So we are clear, right? And then we also understood where these variables are stored. Are they stored in the stack or are they stored in outside the stack? That is also clear, right? In different declarations. Come on. Any doubt you have in this one up to now?
Clear, sir.
Some sir.
Shall we proceed?
Yes, sir.